Welcome to the first section in Python for Bioinformatics. In this we're going to be using math and learning the basics of using Python as a calculator. This is going to take about 26 minutes and you're going to learn a lot. Alright, let's get started. So, what we need to do first is open a new file, create a new file. And I'm going to name this section1.py. Alright. And then let's get started using math in Python. Basically what we're going to do here is make Python our calculator. So let's go ahead and make a comment at the top, and we'll call it using Python as a calculator. And the first thing we're going to do is print 2 plus 2. And I'm going to go ahead and open up a terminal shell real quick. Use one of my fancy colored ones. Alright, and go ahead and CD. Oh yeah, let me increase the size here for you guys. Go ahead and CD to the directory. CD space, and then drop the folder. Alright, and then go ahead, Python section1.py. Make that a little bit more centered. Enter. Prints 4. Perfect. Alright, so now Python is our calculator. Let's do a few more calculations with Python. Something to note, you can put comments anywhere. This is a comment, as you already know. So let's go ahead and let's try this. Print 4 plus 2 plus 7 plus 9. Print 4 plus 6 divided by 2. And then just for a comparison, I'm going to copy that. I'm going to try taking out these parentheses. Let's try print 4 times 3. See this little star right here? That's what you get when you hit shift and you do 8. That stands for multiplication. These stand for divide. And let's give that a try real quick. So you can either type in Python section1.py, or you can just hit the up button on your keyboard and it should give you the last command. So let's just double check. So 422 looks good. 10 divided by 2 should be 5. 4 plus 6 divided by 2, it looks like the order of operations was correct in this. It's 6 divided by 2 first, then 4. So just remember that order of operations does matter. And then 4 times 3 is 12. Perfect. So now we definitely have a working calculator. Alright, just for your knowledge, I want to show you 2 more things. This is the modulus operator. It's a percent sign. And essentially what modulus means is remainder. So for ease of use, I'm going to show 2 divided by 2, the remainder is 0 because 2 goes into 2 exactly one time. There's no remainder. So if we run this, we should get 0. Now, if you have 2 divided by 3, well, what's the remainder? It's 2 because 3 doesn't go into 2 at all. So the remainder is 2. It would be 3 goes into 2 0 times, the remainder is 2. Let's make this a little more interesting. Let's do 20 modulus 2. What would you expect the answer to that to be? The answer is 0, because 2 evenly divides 20. And if we do 20 divided by, or modulus 3, the answer is also 2, because 3 goes into 18 evenly, and there's a remainder of 2. Modulus is really useful. We're going to use it a lot later, but I just want you to understand it just means remainder, and I'm going to put in some additional stuff for you to learn it if you're still having a little trouble with that. Alright, so that's section 1. Let's go ahead and open up a new file. Alright, now we've got section 2. I'm going to put a little comment at the top, make this big. This is going to be called assigning variables. So before we started with print 2 plus 2, and if we run that, I'm just going to change this, we get 4. But there's another way to use variables. So you can say sequence, for instance, equals 2. And now, if we do print sequence plus sequence, essentially what we're saying is sequence is equal to 2, so sequence plus sequence should be equal to the same thing as this. Save that, run it, and we get 4 and 4. So now you're upgrading a little bit. Now we're using variables, and this is where things start to get a little more interesting. Let's say we have bin is equal to 20, and let's say we want to print something useful in our program. So we're going to say the leftover number of bases, and then put a comma, and we'll do bin mod or modulus sequence. Alright, so that might be a good place to explain something real quick. We can print a string, and then if you put a comma, Python knows, okay, print this, and then also print this. So that's all that needs is that comma right there. If you take the comma out, there's a problem. But we know it's going to work, so let's just print that real quick. So now we get leftover number of bases is 0. And that's really, really good and useful. And like we did before on our other section, 20 mod 2 evenly divides 20. So essentially what we just calculated was if we have a bin of size 20, how many different sequences, or will sequences of 2 fit evenly in it, and that is true. We could also do print 20 mod 2 like we did before, and we get the same answer. So that's just, once again, showing something. Now let's just reassign a variable, and in this we're going to use the same name as before, sequence, but this time we're going to give sequence a 3. So now let's see what the answer is when we do the same thing. Now there's a leftover number of bases is 2. I guess we should essentially be saying spots in bin. That's more accurate. Leftover number of spots in bin, and that's 2. So as you can see, this works, and when you reassign a variable, it's top down. So the first time the program sees it, it's what it is, and then right here it's now 3. So from here all the way down to here it's 2, and once you hit this, the computer's like, now it's 3. That's good to remember. You don't want to do this by mistake, because you can obviously get some math errors later on, so just be conscious of that. But it's really useful because then we can use sequence in a number of contexts, and we don't have to say, 3 divided by, bin modulus 3 each time. We can just do bin modulus sequence, and whatever our sequence is, we can just feed it that number as we go. And then finally, I just want to show that this works with anything. So the amount of spots in the bin are spots left in the bin are, and then we can do bin minus sequence, and then when we print this, we get that is equal to 17. So essentially we're saying 20 minus 3, 17. We could do bin cross sequence bin times, using that star, and that's 60, so 3 times 20 is 60. And we can also do, of course, you guessed it, bin divided by sequence, which is equal to 6. 20 divided by 3 is equal to 6. Now, keep that in mind that we don't have the modulus. And notice we get a whole number, which if you do the math, you shouldn't get a whole number. 20 divided by 3, 6.66666. That's actually what we're going to learn in the next section about floating points. So let's get started on that. Alright, make a new file, call this section 3.py, and I'm just going to copy this, learning about integers and floating point. And I'm going to copy this. So what we've got here is like we had before. Let's go ahead and section 3. So we get the answer is 6. So using integers, the bin is divided by the sequence is this. Using integers, bin divided by sequence is 6. Now integers are whole numbers. 0 integers equal whole numbers. So examples, -1, 2, no, -1, 0, 1, 2, 3, ... 9,999, 38. That's all an integer. But let's talk about floating points. Floating points are numbers with a decimal. So 1.0, that's a floating point. 3.9, 99999, that's a floating point. Now let's reassign these variables right here. Bin is equal to 20.0 and sequence is equal to 3.0. And now let's try this little print using floating point. The bin divided by the sequence is equal to, let's see, line 11, non-ASCII character. In file section, no encoding declared. Line 11, non-ASCII character. I'm guessing this triple dot was what was killing it. Let's see. Yeah. Something my text editor added was screwing up Python. But using floating point, the bin divided by sequence is 6.66667. And that's similar to what we calculated up here, where we did 20 divided by 3 is blah, 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 6.627. Now this is the number of digits your computer can do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm counting 12 spaces here. That's not really too important, but that's just something to keep in mind. It will truncate after that many. And yeah, so that's important to know. So I highly recommend using floating point. There are situations where you don't want to use floating point, and we'll go into that. But if you're using math and you're using integers, you're going to get the wrong answer. And take, for instance, let's say you rounded it at the very end using a function in Python. You would get 6 in this version, and you might get 7 since you'd round up in this. So that's important to know. All right, cool. Let's go to the next section. This is going to be the final session in our basic math, and this is going to be showing how you can print your math in beautiful ways in your program. So this is assigning, oops, let me get that bigger, and printing variables. All right, so we can assign a variable to the letter x. And this, we're going to use something fancy. We're going to say x is a string. There are, we're going to put that little %d sign there. Now, don't worry about that right now. I'm going to explain it in a second. Chimpanzees in this, in this lab. Go ahead. And now put a %10. Now what this means is we're saying this is actually a variable and it's a digit. So inside of a string of characters, you can still put a variable, and this is what it is. So we're saying it's 10. Let's give that a try real quick. Make sure I save that. Saved. Section 4. Oh yeah. We still need to be printing it, so let's print x. Try that one more time. And there we go. There are 10 chimpanzees in this lab. Now that's what we wanted. Here, I'm going to type clear just to clear off this, and then show you that. So there are 10 chimpanzees in this lab. Perfect. That's what we wanted. Let's move on a little bit more complex. Let's add one more. So y is, there are, we're going to use the same thing, d, types of chimpanzee. And you might be wondering why I care about chimpanzees at all, and that will become clear actually in a second. Now we can print y. So if we try this, there are 10 chimpanzees in this lab. There are 3 types of chimpanzees. Perfect. We already know that. It's going to work. Now we can add another. Z is, the Latin name for chimp is, and then this we're going to add %s, which stands for string. So the variable at the very end we're going to add as a string, but the Latin names always has 2 strings, so let's add 2 strings at the very end. Now, in order to add a string, you could say, you could add some characters, and you don't have to put the parentheses around it at all. But since we're doing 2 in this string, we have to do parentheses, and then put the first, and then comma separating them, and then the last. And that's the actual Latin name for chimpanzee. So let's go ahead and print that, and let's check that out. Looks like I got an error. Oh, that's funny. I forgot to add quotes because these are strings. The Latin name for chimp is pan troglodytes. Perfect. Works. Just remember to put these quotes around it, and we're good. All right, so let's say we didn't want to use pan troglodytes. We just wanted to have it more abstract. We could say genus is equal to pan, and species is equal to troglodytes. And then when we type this in, we can just do genus and species, and we're good to go. Let's go ahead and print that. Pan troglodytes, perfect. All right, so now if we want to do, I want to show you something else. So far we've only used Z, Y, and X for these crazy string and numbers or string and adding string in things like this for these longer variables. I want to show you that you can do anything. You can name it anything is what I'm trying to say. Within reason, you can name it variable name. For instance, you can't start with a digit, and you can't put spaces, but you can put underscores. And commonly what I'll do is if I have something like, let's say I wanted to call it pan troglodytes, I would do this. I would start it underscore, and then the second would be capitalized, the first letter. I could say, you know, R, my favorite animal. You know, that way it's easy for someone to read this, and it's all just crammed together, and there's no underscores or anything. Of course, I would never make a variable that large. So I'm just going to show you, if you want to say something like variable name, and then this is going to be 3 strings. And then let's go ahead and do chimps, bonobos, humans. Alright, and then we're going to print this a little differently. So we're going to try printing print this a little out of order. Print variable name. Let's give that a try. And I'm going to hit clear to just give you a little room. See. Oh, we got a problem. Line 13, name chimps is not defined. Oh, same problem as before. I forgot to put these in quotations because they're strings. 3 types of chimpanzee: chimps, bonobos, and humans. There are 10 chimpanzees in this lab. The Latin name for chimp is pan troglodytes. There are 3 types of chimpanzee: chimps, bonobos, and humans. Now that's, I don't know the actual scientific backing of that. However, chimps are our closest relative. And scientifically, I do know that chimps are our closest relative, and bonobos are very similar to chimps. So saying there are 3 types of chimpanzee, I don't know if you'd consider a human a chimpanzee, but that we're all very closely related. And so in genetic tests, often chimps are used as ancestors, where we'll often sequence the DNA of a chimp and then cross-reference it to a human. And another one we use is bonobos, but not as frequently because they're not as close as an ancestor. And if you ever look into the psychology of chimps, you'll be kind of amazed at how violent they are, which maybe speaks a little onto our inborn characteristics that we may need to overcome. But let's go ahead, and I want to show you one last thing. If you want to print something like this, now this is a little bizarre because we're using math functions, but we're adding 2 different strings. And let's just see what happens there. And what happens there is we get to see there are 10 chimpanzees in this lab. There's no space, chimps, bonobos, and humans, and that's because up here I didn't add a space. Let's add that space, try that again. There are 10 chimpanzees in this lab. Maybe we'll put a comma right there. Comma, chimps, bonobos, and humans. Now let's say we didn't want to change this one, but we still want to add these variables. Well, we can add a little bit of text in here. So we could even leave this as it was, add this, colon, and a space, and then just add a plus. And now, when we print this, there are 10 chimpanzees in this lab. Chimps, bonobos, and humans. Interesting sentence. Kind of weird. If we change this to Y, like we were using, there are 3 types of chimpanzee. Chimps, bonobos, and humans. And once again, we're running into a little error here because I put in a period up here. So we can just take that out. And there we go. Now we've done math, and we've also shown that it's possible to add our math that we come up with at the very end and different strings into our strings at the very end. All right, great job. Go ahead and, I don't know, put in the outro right here.